In previous time, we studied for Kronig Penney model by solving Schrödinger equation in real space. Then, as I said, the quantum in solid state physics calculate the Schrödinger equation in central equation because of the periodic boundary condition. And here we calculate the central equation in reciprocal space. Central equation is that kinetic energy h bar square k square over 2m minus energy ck plus potential g reciprocal space potential and ck minus g equal to 0. It is a central equation. Let's consider for the delta functional potential. The potential is that amplitude A and A summation for n delta x minus na. It is a delta functional periodic potential. Here the n is the integer in between the 0 to 1 over a because it is a reciprocal space. And the Fourier transform of this Fourier transform of the potential and Vg is that from the integral 0 to 1 dx Vx. Anyway, then it is exponential I gx, but here let's consider only a real part, cosine gx. And here we only, actually, this should have the exponential I gx, g dot r, but here we only take the real part. A real part of the potential. Then a summation for n integral 0 to 1 dx delta functional x minus na cosine gx. Then a summation n cosine g na. Then it should have the amplitude n. Then I will calculate this one. And the summation for cosine gna is that because n is very large, and this summation can be taken as the integral because quantum number n can be very large value, and it can be regarded as continuous value. Therefore 0 to 1 over a and dn cosine gna. From this, the integral g 1 over ga sine gna, and n from the 0 to 1 over a. Therefore it is 1 over ga and sine g. Then in this case, in the approximation, and it is 1 over a. Therefore then the a and 1 over a cancel with each other. The solution is a. Therefore the potential is the a, and the central equation h bar square k square over 2m minus epsilon ck plus a summation for n c k minus 2 pi n over a, because here the reciprocal lattice vector corresponds to the 2 pi n over a. Let's denote that the fk is that for summation n c k minus 2 pi n over a, then the ck is that minus a fk. It is minus a fk, and the denominator h bar square k square over 2m minus epsilon. Then when you multiply by the 2m over h bar square, and the minus 2ma over h bar square fk, and k square minus 2m epsilon over h bar square. Because we know that because of periodic boundary condition, fk is that fk plus 2 pi n over a. Therefore, then let's denote that c k plus 2 pi n over a. Then it is minus k equal to k plus 2 pi n over a square minus 2m epsilon over h bar square, and 2ma over h bar square fk. Let's make a summate in both sides for n. In the c k plus 2 pi n over a, then it is equal to fk, because the summation, this summation for k is the fk, and minus and plus is not important because it is translational symmetry and identical with each other. And it is that minus summation for n k plus 2 pi n over a square minus 2m epsilon over h bar square, 2ma over h bar square fk. Then fk cancel with each other because fk is not related to n. And therefore, here let's multiply this numerator term, and also h bar square over 2ma equal to minus summation for n 1 over k plus 2 pi n over a square minus 2m epsilon over h bar square. Let's make that it is capital K. Then this one is minus summation for n, and it is this part square minus k square. Let's denote this k square. Then k plus 2 pi n over a minus k, and k plus 2 pi n over a plus k, and inverse. Then let's make this part is a and this part is b, and this represent 1 over ab. Then let's make this one as form as the 1 over a minus 1 over b, and it is 1 over c. And basically, and the 1 over a minus 1 over b is that b minus a over ab. Therefore, in this case, and b minus a here, b is that like this, and a is that like this. B minus a is that 2k, and ab represent and k plus 2 pi n over a square minus k square. And therefore, and from this relation, and 1 over ab is that 1 over b minus a times 1 over a minus 1 over b. Therefore, it is 1 over ab, and this term is 1 over ab. Therefore, this h bar square over 2ma is that b minus a is the 2k minus 1 over 2k, and summation for a 1 here, a 1 over a minus 1 over b like this, and also is that let's make a minus minus and plus, and the 1 over b is that 1 over k plus 2 pi n over a plus k minus a 1 over a, k plus 2 pi n over a minus k. Then it is that when you multiply by 2 pi over a over 4k, summation for n, then first part, and 2 pi, multiply 2 over a, and n pi plus a over 2, k plus k, and minus n pi plus a over 2, k minus k. Then here we should use the formula. Cotangent x is that the summation for n equal from minus infinity to infinity 1 over n pi plus x. It is a cotangent. I will use this mathematical formula, and then the result h bar square over 2ma is that a over 4k. That is a cotangent. X means that a k plus k over 2 minus cotangent a k minus k over 2. Let's make that it is alpha and it is beta, and we use that cotangent alpha plus minus cotangent beta is that plus minus sine alpha plus beta over sine alpha sine beta. And here in alpha plus beta is that ak, alpha minus beta is that ak. And therefore h bar square over 2ma is that here minus, therefore it is minus a over 4k here plus minus alpha minus beta is ak sine ak, and sine alpha sine beta. Here also let's use 2 sine alpha sine beta is that cosine alpha minus beta minus cosine alpha plus beta. Then here alpha plus beta is that alpha plus beta is the AK. Yeah, therefore h bar square over 2ma is that sine alpha sine beta here a over 2k sine ak, and also cosine alpha plus beta. Alpha plus beta is cosine ka minus cosine ka. Yeah. Then it can be write down ma a square over ka h bar square sine ka equal to cosine ka minus cosine ka. And let's denote that the p is that ma a square over h bar square, then it is p over ka sine ka plus cosine ka equal to cosine ka. This result is identical from the Schrödinger equation in real space.